The mandatory prac empirical formula of a hydrate is the next prac. And the reason I've put empirical formula of copper chloride is because there is some students who are going to do empirical formula of copper chloride dihydrate, copper chloride dihydrate, because they're at schools that have ordered this, and we should have ordered this, but we actually ordered copper chloride. It doesn't matter, all it means is we only skip one step. So I'm going to go through the steps. The first one's very easy if you're in a school, but it's not easy if you're at home. So if you have this chemical, copper chloride dihydrate, the first thing you do is you put it into a gentle flame to drive the water off, or if you have one, better still, an evaporating dish which is made out of ceramic, and that's what you would have in a school, so that's what you would use. So a quick visual for you is you would have your evaporating dish, it's made of ceramic. You would have a gauze mat, and that's the symbol for a gauze mat. Gauze mat. You would have a tripod. These things are not in the kit, so this is why we're not doing this, tripod. And underneath here in your school of origin you would have a Bunsen burner. It's connected to gas, and you put it on the strong flame, so when you close, when the hole here is open, it's a hot flame, and when it's closed it's a sooty yellow flame. You would want this to be open, so it's a hot flame. So this would be a blue flame. You can hardly see it. That's why when the air hole's closed on your Bunsen, it's called a safety flame, because it turns yellow and you can see it. So a hot flame. You have your copper chloride in here, and it's your copper. Now we're pretending we don't know what it is to prove that we can work out the empirical formula, which you've been studying in class. So we're putting, instead of the numbers that are written over here, CuCl2.2 large 2 H2O, we're using X, Y and Z because we're pretending we don't know what it is. We don't know what X is, we don't know what Y is, and we don't know what Z is. So we put our chemical into this, if you're at a school, and you gently heat it and drive the water off. So on your table here, you would measure out how much you have of your copper chloride dihydrate. And say, I'm just going to use the data that's an example in your actual worksheet. So they've given you some example data. So you would do this 3 times because that's what's required for accuracy. And so this is what they've done. They've weighed it out. That's all they've done. They've got their chemical. Here it is. This is actually not the dihydrate, it's just the copper chloride, but it looks the same. And they've weighed it out, 3 samples, and these are the masses. And then using this apparatus here, they've driven the water off, cooled it, but not allowing water to go back in cans. You'd have to be very careful that you didn't allow it to draw the water back out of the air. And then they've reweighed it. So now you can see that it's the chemical without the water attached. It's just the salt. So this is called dihydrate, and this is called anhydrate. An means no water. Copper chloride anhydrous. That's what we have. I'm suggesting that in cans it wouldn't be anhydrous because there's that much moisture in the air, but that's what we purchased. So we're not going to do this bit, but if you can, do it because it's worthwhile. And so I'm just going to write the example data they have down here. So this is what they got after they dried it. So when they put 1.009 grams in their evaporating dish, drove the water off, cooled it, reweighed it with the electric scales that are in your kit, they got these amounts. I'm just going to write them in. I don't think that will be too difficult for you. And now I'm going to show you the next bit because it is a bit tricky. So what we're going to do from here, I'm going to try and weigh out this amount here so that we can go on. So we're just going, I'm going to show you once, not 3 times. You would do it 3 times. So what I'm going to do now is weigh close to this, 0.80 grams, because our scales only go to 2 decimal places, so we can't actually have 3 decimal place accuracy, and then I'll change this figure. Make sure you put on your gloves, and then we'll do the weighing. And what's easy for transfer and more accurate is if you get a piece of your filter paper and you fold it in half, make a crease in it, put that on your top of your loading tray for your electronic balance. Doesn't matter if it falls over sideways like that. Tear it so it's 0. And now we're going to weigh out 0.8. Or as close to 0.8 as we can. So that's already 0.27, so you can see it's not going to be much. And that's 0.95. So it really doesn't matter what we use actually, but I'll try and stick to what we said. You can see it's very touchy. Okay, let's use 0.85. That's what we're going to start with. Once again, it's important to screw that lid back on tightly because if it's anhydrous, it's going to take water in from the air, and that's called hygroscopic. So instead of this figure, and we're not starting from this point, so I'll just use this box. We're going to write what we started with, 0.85 grams. Now we're going to try and do a chemical reaction so we get rid of our chlorine, so we can calculate how much copper we have. So what we do now is we transfer this carefully into our clean beaker. Give it a tap to try and get as much of that off as possible, which is pretty good. And now we're going to add about 100 mils. It doesn't matter how much water you add. But we do want to have enough water so that we can have a chemical reaction. So let's start with 100 mils. As I said, you don't have to be looking very careful. It's about 100 mils. Pour it all in. Get your spatula. Give it a stir. You can see it's got this nice lime sort of colour. Going yellower by the minute, so we'll just keep stirring until we can try and get that to dissolve. It's not as soluble as I thought it would be, but just keep stirring for a little minute. Be patient. Also much yellower than I thought it would be, because normally copper compounds are green or blue, so I'm surprised by this colour, but it's okay. So what we're going to see now is actually what's called a metal displacement reaction. And you already have studied this, but just a reminder, on the side here, move some of these stickers so that we can use the board. So if you have a metal in solution, which is what we've got, doesn't matter what the anion is, so we've got copper chloride, which essentially is copper ions floating around with chlorine ions. They're separate, so these copper ions are floating around. So if you have a metal in solution and you add another metal to it, like we're going to, so it's a scrunched up bit of aluminium foil, if this solid, now this is a solid, this solid metal is more reactive than the copper that's in solution, they change places, as bizarre as that sounds. So what will happen is copper, after time, copper will come out as a solid, so you'll see like a brown coppery colour, so it'll be copper solid on the bottom, sort of like a sludge. It'll be a brown sludge, and you'll see the aluminium dissolve in. You have aluminium ions floating around. Now what happened to the chlorine? It's still there. So now it's aluminium chloride instead of copper chloride and copper solid. So that's what we're trying to do. We're trying to remove the copper so we can weigh it, so we can get the empirical formula, prove that this is the empirical formula, because at the moment we've got X and Y. We're trying to prove, this is actually called the molecular formula, but it's also the empirical formula, as you know. So that's where we're headed. We're going to put some aluminium in and we're going to try and get them to swap. So this is our final stir. I can see that not all of it's dissolved, but we'll just hope that over time it will. Put this on the paper towel. So there's no science really to this, because I don't know how much it's going to use. It doesn't matter if it's not all used up. So you just scrunch it up like this, give it a bit of surface area and poke it in. And then you should see a reaction happen pretty quickly. Leave this overnight, and in the morning we might find that the copper has come out and the aluminium has gone in. Starting to get the aluminium dissolving in like I was talking about, and the copper coming out, and you can really see the copper coming out. It's a brown, it's dark browny mauve colour. That's the copper as a solid, and the aim of what you're going to do is you're going to remove the aluminium, filter this brown fine powder out, which will be easier once it settles to the bottom, and then weigh the dried filtrate, and then you'll have the mass of the copper, and only then can you determine the empirical formula of copper chloride. Take out our foil. We'll wash it with our wash bottle very carefully. So this is our wash bottle here. You've got one of these in your kit. So just putting this on. You'll lift out your metal. You'll wash it off as best you can, getting all that, as much as you can get removed as possible. It's going to be a bit tricky actually. In fact, you might be better off not scrunching it and just you might be better off cutting strips, because that'd be easier to wash off and putting them in, because you can see a lot of excess there. And then once that's settled, you will filter it. So you'll get your filter paper, a clean piece. When you filter something, you fold it in half, and then you fold it in half again, and you open it up to make a little cone. And then you get your filter funnel. You just run a little bit of water from the tap in there just to wet it, and this will make this stick. It sticks in there, and then you can hold it in one of your beakers. You have a 400ml beaker and a 250ml beaker. Either one will do. I'd probably use the big one. When this is completely finished and you've washed all the aluminium and got it all off, you can use as much water as you want. You just have to filter more. You will pour this in through there. All of the water will come out looking like water. The filtrate will come out looking like water, but it's not. It's aluminium chloride, but it will be clear if you've done a good filtering job. And in here will be your browned pure copper. You take this out, just imagining there's brown pure copper in here. You lie it flat in a safe place and allow it to dry. So you can see that it's important that you've thought about this and weighed your filter paper before doing it, because then you can take it off. They all weigh very, very similar, but to be most accurate, you weigh the piece you're going to use. But if you haven't and you forgot to do that, you'd weigh another piece that's empty, take it off your dry, because you're not going to get it off here. You're going to have a dry copper powder stuck to this that you've weighed, and then you write that result in here, and then the next video I can show you what to do with your calculation.